Hello and welcome to Statecraft IAS Academy. I am Atif, your geography educator. We have for the past some time seen some students struggling to connect the static content with current affairs. What most of the students do is they will read the static content, then go through the current affairs, be it newspapers or magazines, but they fail to link the two. And that is what exactly the exam demands from you. If you look at the exams, be it prelims, be it mains, what happens in the exam? The questions will be based on the linkage between two. For example, I will tell you how it works. You might all be aware of the recent events that have taken place in Europe. The extreme heat wave that killed more than 1500 people in a matter of few days. You will all be, or maybe not all, but maximum, you will be aware of jet stream. But the thing is, are you able to connect the two? Jet stream has a direct role in that heat wave. What will happen in the exam? The question will be asked based on the linkages. For example, the question will be, explain the role of jet stream in the recent extreme climate events. So there you should have knowledge of static as well as the current events that are taking place. And it applies in both prelims as well as mains. That is why I have decided to bring this series for you, where we will link the two. We will link the static with current affairs, so that you can easily qualify the exam. Your concepts become clear. Today, I will bring the basics of climatology to you. We will have least current affairs in today's class, but let me tell you something very important. Today's class will play a huge role to make your basics clear so that whenever you go through climatology, it becomes a cakewalk for you. Because today will be the class that will make the foundation for you. So I request you all to be attentive in the class so that from tomorrow onwards, when I bring the classes that will be related to current affairs, you don't get confused how the things are going actually. Today, it will lay the foundation for you for the upcoming classes. Hopefully, you will be able to understand today's class, and then from tomorrow onwards, you will easily get everything. So let's start. Starting with basic. What is a wind? Wind is the movement of air. True. But this is partially correct. This is something we should know. Wind is horizontal movement of air. First of all, remember this word horizontal. It is very important. Why? Because air can move vertically as well, horizontally as well. But when we talk of wind, it is only the horizontal movement of air. Horizontal movement like this. Look at the arrow. The movement like this, like coming from the front, coming from the sides, coming from the back. Then you might wonder, sir, is there some movement vertical as well? Yes, of course. There is vertical movement of air as well. That I will show you in today's class. We call them currents. But when we talk of wind specifically, wind is only the horizontal movement of air. If until now you thought that movement of air is wind, moving air is called wind, that's not true. That's true but partially true. Horizontal movement of air is wind. The question arises, why does the air move? Why will it move? What's the reason? If you're sitting somewhere, there has to be a reason that you will move. You're sitting in a chair, there has to be a reason for your movement. Similarly, what is the reason for the wind to move, the air to move? There are primarily three forces that drive the movement of air, that drive the wind. Three forces are responsible for the movement of air. Okay, what are the three forces? Number one, pressure gradient force. Number two, Coriolis force. And number three, frictional force. These three forces are very important and they play a huge role in the movement of air. We will learn them one by one and see how exactly each force is responsible for the motion of air, for the winds. Starting with the very first, we'll get back to this table once we learn all the three forces. We will come back to this table so that the things that are written here are clear to you, and then I will tell you what's written here. First, we will learn them one by one. First and foremost, we talk of pressure gradient force. As the word here is gradient, what is the meaning of gradient? Gradient basically is difference. It's talking of difference between two things. So there is a gradient that's formed. How? Let me give you a very simple example first. Let's say we have a place like this where we have a slope. This is a ground with a slope. If we drop water here, what's going to happen? The water will come down the slope. Why will it come down the slope? Or let's say we have a slope like this. We drop water here in the middle. The water will come down. Or will it go up? Never. It will not go up. It will only come down the slope. Because this is how the water moves. Similarly, in case of wind, it moves from high gradient, high pressure towards low pressure. Whenever we have a high pressure condition, the wind will start to move from that very place to a region where we will have low pressure. If you look at the first image here, that in this region we have a lot of air particles. So the gradient here, the pressure is very high. And on the other side, you see less number of particles. So the pressure is low. More the particles, more will be the pressure. But since on the other side, we have low number of particles, the pressure is less. What's going to happen? From high pressure area, the wind will start to blow towards low pressure area. You will never see the wind blowing like this. That is from low pressure to high pressure. It's like water going up the slope. Is that possible? No, because there is a way how the things work. Similarly, in case of air, whenever we have a high pressure condition, the wind will start to blow from high pressure region to low pressure area. So, pressure gradient force is primarily responsible for the movement of air. What else does it affect? It affects the speed as well. When we talk of speed, speed is also impacted by the pressure gradient force. How? Now look at the second diagram. We have a pressure of 1020 here and a pressure of 1012. So let's say a difference of 8. High pressure on this side, low pressure on this side. So the wind is supposed to blow like this. Right. This is how the wind will blow. Correct. In the second case, we have a high pressure of 1020, but at the same time, a low pressure of 1004. That means a difference of about 16. More difference. That means a strong gradient will be created as compared to first. A very strong gradient will be created in case of this second one as compared to first. When the gradient is strong, when the pressure difference is more, the speed is high. High speed is associated with more pressure gradient, steep pressure gradient. So when we talk of the first example, we have shallow pressure gradient, so the low wind speed. At the same time, when we talk of the second example, we have a steep pressure gradient and high wind speed. First and foremost, you have to remember two things. Pressure gradient force is the force that is responsible for wind. Number one. Number two, stronger the pressure gradient force, high will be the speed of the wind. Shallow the pressure gradient, the speed of the wind will be less. Two things that you need to know here. First, it starts the wind, and second, it also impacts the speed of the wind. So this is the first force done and dusted. Let's go to second. Second force that impacts the movement of wind is Coriolis force. Coriolis force. Coriolis force is a force that is caused due to the rotation of Earth. Due to rotation of Earth, we have force that is generated called Coriolis force. And what it does is, whenever anything is moving in the northern hemisphere, in this sphere, that's northern hemisphere, it will be deflected towards right. Let's say anything was supposed to travel like this, but due to Coriolis force, it will be deflected towards right. And in the southern hemisphere, everything will be deflected towards where? Left, like this. Now, I have something to tell you. Some of you might get confused that in both the cases, it's turning towards right. See, this is right, this is my right, this is my right. But you don't have to see your right. You have to see the direction of the wind. You have to always look at the arrow that is there. This arrow will determine the direction the Coriolis force is going to do. So whenever you look at this arrow, this is towards north. So its right will be like this. But at the same time, if the arrow is like this will be the left. Just don't get confused. This is something very important that you will also be required in case of reverse, how they are right bank tributaries and left bank tributaries. There also, you don't have to see your right and left. You have to see the left of the moving object. Coming back to the topic, when we talk of Coriolis force, it causes deflection in any moving object. To the right in northern hemisphere and to the left in southern hemisphere. Number one. Number two, always remember the deflection is more when the velocity is high. In simple words, let me tell you, if something is moving very fast, the deflection will be more. If something is moving slowly, then the deflection will be less. So what's it? The velocity will impact the Coriolis force, but at the same time, the vice versa is not true. What does that mean? Coriolis force will not impact the velocity. For example, if there is Coriolis force that is deflecting something like this, is it going to impact the velocity? Not at all. But if something is moving fast, in that case, the velocity will be responsible for the deflection. If the velocity is more, deflection will be more. If the velocity is less, deflection will be less. That's number one. Number two, very important thing that you need to know is on the equator, in this very region, Coriolis force is zero. There is no Coriolis force at all on the equator. And at the poles, North Pole or South Pole, the Coriolis force is maximum. Deflection will be more on poles as compared to equator. These are two important things that you need to know. Everything deflected towards right in the northern hemisphere, towards left in the southern hemisphere. At the same time, higher the speed of the moving object, more will be the deflection. And the Coriolis force is zero on equator and it will be maximum on the poles. Because of this Coriolis force being zero on the equator, we will see there are no cyclones there. We will learn about that when we reach there, but right now remember this thing. But why is this Coriolis force deflecting everything? Basically, let me give you a simple example in layman terms. It's not actually how it works, but I'm going to give you a layman example. For example, this is Earth and this is equator. Okay, let us say this is a car that is moving in this direction. And at the same time, we have one more car that's moving here in this direction. When we look at the Earth, we see Earth is in what shape? It's in spherical shape. So what happens is at the equator, the speed of rotation is more. The speed of rotation is more as compared to poles. At poles, the speed of rotation is less. If a car is moving here with less speed and a car is moving here with more speed, what's going to happen? Let's say the car is moving towards this and it wants to throw something towards this very car. What's going to happen? Because of slow movement, it will be left behind and the object will fall in front of it. Let's say towards right. This is a layman example. Basically, what I'm trying to tell you here is that how the Coriolis force is responsible for shifting of the direction. Now, long story short, let me summarize this thing for you. Long story short, let me tell you, Coriolis force deflects everything towards right in northern hemisphere and vice versa in southern hemisphere. That means towards left. That's number one thing. Number two, it is zero at equator and maximum at poles. Number three, more the speed of moving object, it can be wind or anything, more will be deflection. Hopefully, This much you have understood. Now coming to the last force, that's frictional force. This is very simple. You know this, you read about this from school. Frictional force is something that resists the movement. For example, this is a boy who is trying to push this block of wood. When he pushes it, there will be a frictional force that will resist its movement. So frictional force is something that resists the movement. It impacts the speed of the wind. That means it will try to reduce the speed of the wind. Okay, number one. Number two, why is frictional force created? Of course, when something rubs with something, let's say my hand is rubbing on my other hand, a friction will be created. So when winds are moving on the surface of Earth, near the surface of Earth, it rubs against land, against mountains and other features as well. So it faces friction. At the same time, once the air starts to move at a certain height, there will be no frictional force. It will reduce after a couple of kilometers. When you go 3-4 kilometers higher, you will see absence of frictional force. It is restricted only to a few kilometers, a couple of kilometers. After that, there will be no frictional force. In simple words, if I'm rubbing my two hands, what's going to happen? There will be friction. But if I'm moving my hand like this, away from this surface, there will be no friction. Same is the case with air as well. When it's moving near the surface of Earth, the friction will be maximum. As it starts to go up, there will be no friction. So three forces responsible for this are frictional force, Coriolis force and pressure gradient force. Now come back to this where I told you what is written. In the first part, you will see pressure gradient force is caused due to difference in air pressure, as I already told you. Coriolis force is caused due to rotation of Earth. This is also mentioned. And frictional force is something that resists. Now, how is the interplay of these three forces responsible for wind? Look at this diagram now. When we look at this very arrow, this is a pressure gradient force acting in this direction. Normally, the wind should move like this. Okay? But we have one more force, that is frictional force, that is acting in this direction. And always remember, wind moves as a resultant of the two forces. What is the meaning of resultant? That means it will move in between the two. It will move in between the two. Okay, it will try to balance both the forces. It will try to balance both these forces and it will move in between the two. Then what is the role of frictional force? You might wonder, okay, if wind is a resultant of these two forces, then what is the drag force or the frictional force doing? As I already told you, frictional force is something that is reducing the speed of wind. If the speed of wind is less, then frictional force will be less. If there was frictional force absent, if the frictional force was absent, then it would have been something like this, because there will be more Coriolis force. But since there is drag force or the frictional force, we see the movement of wind like this. Like this. So this is how the three forces operate together and try to generate wind. These are the wind generating forces. I hope everything is clear till now. This was something regarding the wind, how the wind is generated and how the frictional force, Coriolis force and pressure gradient force is responsible. Now we come to the main point where we have to talk of climate. How the pressure belts, global pressure belts are impacted because of forces. Okay, now I know all of you, when you are in school, you know about this thing that Earth is in constant revolution around the sun. It revolves around the sun like this. And this revolution is responsible for creating seasons. Let's say when the sun is in this position and Earth is here, it's the situation of 21st June. It is summer season. Then the Earth will start to rotate. It will reach here. It will be autumn in September. Then winter season in December. And finally in spring, it will be in March. It will be spring again. Now, let me tell you something very important. This is the reason we see there are pressure belts. There is certain movement of wind. There is formation of seasons. There is rainfall. There is sunshine. Everything is responsible for because of this thing. This thing is responsible for everything. Now, let's move forward. How is all this happening? Let us say, let's take one example, this one, summer season. When the sun is overhead, First of all, my drawing is very bad, so I hope there's no problem. When the sun will shine overhead, what's going to happen? It's going to heat the ground. Okay, look at this very situation. The ground is hot in this region. When the ground will be heated up, what's going to happen? The air will start to go up. Warm air will always rise. You should know this thing. Whenever the air is warm, it starts to rise. It starts to go up. So when the sun is overhead in this position, it will heat the ground. And once the ground is hot, the air will start to ascend. The air will start to go up. And in case of cold air, it descends down. Are you getting my point? Warm air will always ascend. It will always go high. Why? Because it has less density. The particles will expand. In short, long story short, let me tell you, warm air always goes up. It ascends. And the cold air will come down. It will descend. This creates a condition of pressure gradient. How? See, for example, at this place, the sun is shining and the ground is hot at this place. When the ground will be hot, the air will also heat up and the air will go up like this. Correct? Once the air goes up from somewhere, what's going to happen? At the ground level, the pressure will be less. Why will the pressure be less once the air goes up? See, it's very common sense. If you take a look at this, let's say there's air on the ground. Look at me right now. Look at my hands. This is ground and this is a parcel of air. It is putting some pressure on the ground. Once the air starts to heat up and it starts to go up, it's going up. What happens at the ground? The pressure is getting lifted as well. So the low pressure conditions will be here because the pressure that was here is going up because of air. The air going up, the pressure conditions here will start to fall. So we will have low pressure conditions. At the same time, once the air is cold and it comes down, what will it do? The pressure will increase. Again, the same example. This is ground, this is air, it's coming down, so it's going to put pressure on the ground. So in this condition, we will have high pressure conditions. Now, I told you in case of pressure gradient force. What did I tell you? Pressure gradient force is something that is between a high pressure area and a low pressure area. We have a high pressure area here and a low pressure area here. So the wind will start to blow from this place towards this region. Why? Because a high pressure condition is created here and it has a low pressure condition and the winds will start to blow towards this region. Clear? Are you getting what I'm saying? When the air goes up here, the air will start to accumulate at this region. So a high pressure condition will be created here. At the same time, a low pressure condition will be created here as well. Why? Because the air is going down. So when the air goes down, a low pressure condition will be here. So at the top, the air will start to move from high pressure towards low pressure. This is how the cycle of atmosphere works. And this is exactly what you will see in the trimeridinal circulation of air. And that is something that is directly asked in the exams. I have seen questions asked from that in prelims, in mains, in other exams as well. In every exam, you will see trimeridinal circulation being very much asked. So you should be able to answer that after this class. Now let's go to that thing. Now listen to me very carefully. This is the summer season. This is the autumn season. And this is spring season. Most of the times what you see is the sun is located near the equator. In summer, it is on the Tropic of Cancer. In winter, it's on Tropic of Capricorn. But for most of the time, you will see the sun on either in spring, in autumn, you will see it on the equator. So let's draw a condition. Now, this is something, if you're watching the video, take a pen and a paper, please draw this thing because this is a drawing that is actually going to help you a lot. Now listen to me very carefully. This is ground. I'm drawing a flat surface. I know most of you will be like, sir, no, ground is not like this. Ground is spherical. I know that. But for the ease of understanding, please have some patience. We will go to spherical ground as well. Right now, ground is like this, okay? And this is 0 degree or equator. Equator or 0 degree. What happens is once the sun starts to shine over the equator, okay, what's going to happen? The ground will heat up. This ground will start to heat up. And if the ground heats up, what will happen? The air will heat up. When the air will heat up, the air will start to go up. What I mean to say is, once the sun is here and the ground is hot, the air will start to ascend. It will start to go up. Now, don't get confused as, sir, why is the sun here? I'm telling you, let's assume the condition is of spring and autumn when the sun is shining over the equator. So, in that very condition, the air will go up. After going up, and when it reaches to tropopause, you know about the layers of atmosphere. If you don't know, please let me know in the comments. I will bring a class on that as well. How the layer of atmosphere are there, what is tropopause, what is troposphere, tropopause, stratosphere. But as of now, I assume that you know that thing because that's very basic. So once it reaches the tropopause, it will start to diverge like this. Okay. And it will happen on both the sides. What is the meaning of that? In northern hemisphere and in southern hemisphere. Like this. Okay. Listen to me very carefully. This is the northern hemisphere and this is southern hemisphere. Once the air diverges near the tropopause, it will start to move in both the hemispheres like this and this. But after some time, when the air will move, first of all, the temperature of air will fall. It was hot near the ground. It will start to rise. But once the air will go to a certain height, the temperature in the upper atmosphere is very low. So air will start to cool down. Along with cooling down, the Coriolis force will also act that will deflect the air. So the air will start to accumulate at a place. Now, the air is very cold. If warm air rises up, the cold air will start to come down. The cold air will start to descend. Why? Because warm air rises up. And I told you cold air will descend. I told you already this thing. So the cold air will start to come down. Okay? Like this. Now, let me tell you something. Whatever I'm doing here now is happening on both the sides. That is northern hemisphere as well as southern hemisphere. But right now, I'll only draw in the northern hemisphere because the same thing will happen on the other side as well. So right now, only look at this very thing. Now, when it will reach the ground, what's going to happen? This is a position around 30 degrees. 30 degree. Listen to me very carefully. I told you already, once the air goes up, what happens at that position? On ground, we develop low pressure conditions. Right? I explained you already how. If you don't know, just please rewind the video and watch it. I told you why the pressure is low. At the same time, when the air is coming down, it will put extra pressure. So the condition here will be high pressure. That means a pressure gradient is created between the two. So what's going to happen? The wind will start to flow from high pressure area towards low pressure area. Same thing will happen on the southern hemisphere as well. Let's take only northern hemisphere and you can expect the other thing to be same. Correct? This is what's gonna happen. Now, moving forward, what's gonna happen near the poles? 90 degree. What will happen at poles? You know, at 90 degrees, the temperature is very cold. So the air will be very cold and cold air has a tendency to sink. It will come down. Like on 0 degree, the air was warm, so it went up. On poles, the temperature is very, very less. It's in minus. So the air will come down obviously. If warm air goes up, the cold air will obviously come down. Am I right? This is cold air coming down. Correct? At the same time, when we look at the subtropical high pressure region or this very region where I told you the air is coming down, this position. Okay? What's going to happen here? The air will start to flow, right? Like this. The air from the poles will also start to flow, like this. And they will meet at a position near 60 degree. When they reach near 60 degree, what's going to happen? When the two air will come, look at me, look at me, look at me. Don't look at the screen, look at me. The air from the one position and from the other position is coming. When they're coming towards each other, they will come and start to rise like this. They will go up like this. Okay, they will start to go up, and the air here will also start to go up. I hope this is very much clear to you. Are you getting my point? If you have any confusion, please let me know in the comments so that I can clear this thing. Next time when we are in the class, I'll read your comments first and then take all the doubts. This is how the circulation of air in the atmosphere takes place. The same thing will happen on the other side as well. Now, don't you think they are formed like boxes or cells? Yes, exactly. First cell is called Hadley cell. This is your first question. What is a Hadley cell? The cell that's formed between equator and 30 degrees. This is Hadley cell. The second cell that's formed between 30 degrees and 60 degrees is Ferrel. Ferral. And a cell formed between 60 degree and 90 degree is polar cell. Long story short, after studying the trimeridinal circulation, you will see formation of three cells: Hadley cell, Ferrel cell, polar cell. Same thing will happen in the southern hemisphere. You will have one Hadley cell here, then you will have one Ferrel cell here, and then you will have one polar cell here. Now, if you are drawing this thing, let me tell you something. If you have noticed it, the diagram is somewhat like this. The cells are not of uniform thickness. Okay, you have to draw it like this because this is how our troposphere is. Why? Because when the temperature is more, the air will go higher. Correct? When the temperature starts to fall, the air will not be able to go that much higher. So the air will be low. The atmosphere height is less. That is why at the equators we have the height of around 18 kilometers of troposphere. At the poles we have only 8 kilometers. This is not by chance that I drew it like this. This is how the shape of the atmosphere is. How at the equator it will heat up, the air will start to go up, then it will come down at 30 degrees. So there will be a pressure gradient, low pressure and high pressure conditions. The air will start to flow between the two. Then again we will have polar cell, Ferrel cell, and I already explained you how they are formed. Now, if any one of you have confusion, let me just show you like this. Let's say this is Earth, this is the equator. What I'm trying to tell you is that on the equator, the air goes up and then it will come down around 30 degrees, somewhere here. Okay. On the poles, the wind will come down again. And then we will have somewhat like this. And this is how the three cells will be formed. Or if you look at this diagram, this is exactly what I was trying to show you. This is the first Hadley cell. You can see on the equator, the air going up. Then it will come down around 30 degrees. At 60 degree again, it will go up. And on the poles, it will come down. Exactly what I tried to show you here. I hope this is clear. Now, one important thing that you need to know here is that because on the 0 degree on the equator, it is because of temperature the air was rising. Okay, so this is called thermally induced pressure belt. Thermally induced. What is the meaning of thermally induced? Because of temperature. This is because of temperature. And same thing at the poles. This is also because of temperature. So this is also a thermally induced. Why? Because temperature is responsible. Low temperature, sinking air. High temperature, rising air. So we have a thermally induced pressure belt on 0 degree and thermally induced pressure belt on 90 degrees. And one more thermally induced pressure belt will be in 90 degrees south as well. As I told you, the same thing will happen in the southern hemisphere as well. So we have a total of 3 thermally induced pressure belts. What about the other two? See, this air is coming down and putting high pressure on this region. Same thing. This is going because of the collision of the two airs. So these are not thermally induced. These are dynamically induced. Okay, dynamically induced. These two, and the same again on the southern hemisphere. 2 plus 2 is 4. Dynamically induced. So a total of 7 pressure belts are located on Earth. Now you might wonder, sir, why do we need these pressure belts? Let me tell you something. These pressure belts are responsible for all the weather phenomena that take place on our Earth. You will see that one by one, each and every phenomena, jet streams, western disturbances, rainfall, snow, all these because of these pressure belts. Now take a look at this diagram. This is what I was trying to tell you. When we look at the sphere of the Earth, this is equator here, where the air rises, then comes down. Again, the air comes down, rises, and these form pressure belts like this. I hope this is clear to you, and I hope there is no confusion as of now. If there is any confusion, you can let me know. Now, when we talk of pressure belts, we have given them specific names, certain names. Okay. First of all, let's talk of this 0-degree pressure belt. Low pressure. Okay. When we talk of 0-degree pressure belt, it is called as equatorial low pressure. Equatorial low pressure. It's written already. I hope you are able to read it, but if it is not visible clearly, that's why I'm writing it down for you. This is on equator. When we go to 30 degrees, I told you we have high pressure conditions there, right? This is called as subtropical high pressure belt. High pressure belt. Okay. Then going to 60 degrees, again a condition of low pressure. What's it? Subpolar low pressure belt. Subpolar low pressure belt. And finally, on poles, I told you a high pressure condition is created. We have high pressure, polar high pressure belt. Now, tell me something I already told you here. Look at this. I told you the wind moves from high pressure towards low pressure. That is from 30 degree, what we named as subtropical high pressure belt, towards 0 degree or equator. Only this much right now. Please pay attention very carefully. You need to imagine this thing. I'm talking of wind from 30 degrees to 0 degree. That is from subtropical high pressure belt to equator. That means from this region towards this region. That means the winds need to blow from this region towards this region. Okay, from here to here. But this is a very interesting thing. If you look at these arrows, these are somewhat like this, curved, not straight. Ideally, high pressure to low pressure should have been straight, like this. Ideally, the thing should have been like this, but they are a bit curved. They are not coming straight from high pressure to low pressure, but they are coming like this. Why? What is the reason? I told you there is Coriolis force that deflects everything in the northern hemisphere to right. Is this right? Don't get confused. Again, I told you, look at this arrow. The arrow is downwards towards south. So if you take a look, the right will be like this and not here. No. If it would have been like this, then right would have been like this. But since the direction is like this, so this will be our right. That is why the wind blows like this. Now, this is about northern hemisphere. What will happen in the southern hemisphere? Again, the winds need to blow like this, but they will again change their direction. They will again be like this. So now why are they like this? Because they need to go like this. And in case of southern hemisphere, the wind is deflected towards left. And what's left? Look at the arrow. Arrow, you need to look at the arrow. Left is this. In case of north, the wind was moving like this, so this was right. Now it's going like this, so we will have this as left. And these winds are called as easterlies. Why? Why are they called as easterlies? What's the reason? Remember one thing, whenever you talk of any wind in geography, we name the wind from the direction from which it's coming. If you don't know about the directions, this is east, this is west. Now wind is coming from east and going like this. So it's coming from east. So we name it as easterly. So these are called as tropical easterlies. Or in other words, if you look at this diagram, these black arrows that I'm showing you here, these are easterlies. Okay. Going to next. When we look at subtropical high pressure to subpolar low pressure. High pressure is this, low pressure is here. This is high pressure. Wind needs to go from high pressure to low pressure. It should ideally move like this. But there's Coriolis force again. It will deflect the wind towards right. And what's the right of this arrow? The right of this arrow is like this. Like this. Same thing will happen in south as well. I told you whatever is happening in northern hemisphere, same thing is happening in the south. In south, the wind will be deflected towards left, and this is your left. Ideally, it should have been like this. Now you need to be very clear. These are called as what? Since they are coming from west and going towards east, they're coming like this. So these are named as westerlies. Westerlies. Going back to our diagram that we just drew, these arrows are westerlies. On the ground, the wind is on ground. Don't go to upper air circulation. No, don't go there. These are called as westerlies. And finally, we have a high pressure condition around the poles, and the wind from high pressure will come towards subpolar region. Now I don't need to repeat it why the wind is curved. You have already learned this. I have told you this multiple times. The direction gets deflected, and these are called as polar easterlies. What are they known as? Polar easterlies. Easterlies in both the cases, but that's tropical easterly. These are polar easterlies. I hope everything is clear. If I have any place, let me tell you very quickly what I told you. See, we will have easterlies in between 0 degree and 30 degree. We will have westerlies between 30 to 60 degree. And we will have polar easterlies between 60 to 90 degree. This is the direction of wind. Coming back to our main question, okay, we learned about it. But what exactly is the role of these things? How do they impact the climate? How do they impact the climate? What's their role? Any specific role? Yeah, yes. They are responsible for rainfall and aridity. Let me see how. Remember something, whenever the air is going up, it will lead to rainfall or formation of clouds. Hopefully you read this because this is something in primary school that moving air, whenever the air goes up, it forms clouds. Why? Because it loses the specific heat, the relative humidity, other things. Right now we cannot mix the two, otherwise it will be very difficult. But one thing I want to tell you is whenever the air will go up, it will cool down and it will lead to formation of clouds. Okay, it will lead to formation of clouds, moving air going up. So that means whenever we talk of any place where the air is going up, that place will be associated with rainfall. Am I right? Because when the air will go up, it will form clouds, it will cause rainfall. Now take a look at this. I told you on the equator, the air goes up. So that means we will have cloud formation here. The clouds will be formed in this region. And these clouds are responsible for rainfall. That is why whenever you talk of equatorial climate, we have rainfall throughout the year. throughout the year we will have rainfall, with a couple of months where there is less rainfall. Otherwise, we will see at least 9 to 10 months where the rainfall will be intense on the equator. Why? Because the air is heated, it goes up, it leads to formation of clouds. Look at the clouds formed on the equator. This is 0 degree. The clouds are formed and this will lead to rainfall. So what is the first thing that you need to understand here? Whenever the air will go up, it will form clouds that will cause rainfall. Same thing applies to 60 degree as well. This is our 60 degree where the air was going up. So we will have cloud formation here as well. That means 0 degree, 60 degree is associated with non-stop rainfall, continuous rainfall. And this is true when you take a look at these pressure belts, you will see rainfall throughout the world, throughout the year. What about the other thing? When the air is coming down? Whenever the air will come down, it will lead to stable conditions or aridity or clear skies. There will be no formation of clouds. This is very important. You need to understand this because we will learn about the climate crisis of Europe. Maybe tomorrow, not today because the class is already gone too long, but tomorrow I'll tell you. So whenever the air will come down, it will lead to stable conditions. There will be no rainfall. What is the meaning of stable conditions? No rainfall, dry weather. And whenever the air will go up, it will lead to instability or weather or cloud formation, rainfall. But whenever the air will come down, it will lead to aridity. Now I'll tell you something very interesting after this. I told you already on equator we will have rainfall throughout the year. But have you ever wondered? Well, there are other reasons. Let me clear this first. There are multiple reasons. But one reason is this. If you look at these deserts, look at these deserts. Okay? The line that I'm drawing, watch it very carefully. The dark areas in this map show the deserts of the world. Can you see a pattern here? All the deserts are located on this very line. Most of the deserts. I'm telling you again, don't think that this is the only reason, but this is one of the very important reasons. Most of the deserts, if you look at here, Mojave Desert, we have Sahara Desert, we have Arabian deserts, we have Dashtilut, Thar. In the southern hemisphere, we have Patagonia Desert, we have Namib Desert, Kalahari Desert, then some deserts in Australia as well. These are located on this very line. Why is it so? What's the reason? What do you think? Because this is a region of subtropical high pressure region. And I already told you, let's say this is equator. Okay, this is the equator. The air will ascend from this region and then start to descend around this region. Once the air will start to descend around this very region, you will see descending air is responsible for aridity. I told you already. I hope there is no confusion in this. That is why these regions see a lot of deserts in the northern hemisphere. Same will be the case in southern hemisphere. I think this much you have understood now. Whenever I am talking of northern hemisphere, it applies to southern hemisphere as well. If there is some exception, I will mention that specifically. But as of now, whatever I told you about the northern hemisphere applies as such to southern hemisphere. Okay, so hopefully you got this thing very clear that these regions have deserts because of this thing. Clear? This is about the trimeridinal circulation of atmosphere and how the atmosphere works. I hope everything is clear. The force is responsible for formation of wind, how the wind works, how the trimeridinal circulation is created. Now, this is from where we will build this very image. Keep this in mind, how frictional force is responsible for reduced Coriolis force and the direction of wind. Tomorrow, when we come or whenever I'm taking the next class, I will tell you the conditions in Europe right now and how those conditions are directly impacted because of the jet streams, how jet streams will be formed. Today, there was not much of current affairs. You might be confused, sir, you told about current affairs and all. I told you already, today's class will be to build the foundation. for the upcoming classes, because from tomorrow onwards we will have classes linked to current affairs. But you would not be able to understand those current affairs if you are not clear about the basics that I told you in today's class. Hopefully everything is clear. Again, if you have any confusion, anything in your mind, kindly let me know in the comments. Drop a message. I will address your problems either in the comments or in the next class. Okay? Hopefully everything was good and you enjoyed the lecture. See you next time. Till then, bye-bye.